Hey guys, this is Mr. Grice for Algebra 2, Chapter 3.8 Notes. Today we're talking about solving compound inequalities involving OR. Our learning target today is to be able to solve compound inequalities involving the word OR. Okay, so a couple reminders when you're solving that you need to solve each inequalities separately whenever you see the word OR, and then graph both of them on the same graph. Okay, so let's go ahead and get started with this. We already see the word OR, so that just tells me, hey, these are two separate ones. Okay, so to solve for x, we need to add 2 to both sides, and then we get x is greater than or equal to 3. On the right side, to solve for x, we need to divide both sides by 2, and we get x is greater than 5. Okay, so this part right here is part of our answer. Okay, but now that tells us what to graph. Okay, we have 3 and 5. Are we open or closed to 3? We're closed, and then we shade to the left. At 5, we're open, and then we shade to the right. Okay? And now the next part of our answer is we need to put this in interval notation. Okay? So our graph starts at the left, so that means we start at negative infinity, and then it stops at 3. It's closed at 3, so that's why we have a bracket. And now, see this break right here? That break is our OR, and that's where we put a giant U. That means union. Okay? And then we start at 5, start back up at 5 where it's opened, and we close at positive infinity. Okay? So anytime we have a break right here, that break pretty much means union right there. We're putting those two things together, the two inequalities together. Okay? So once again, we have the word OR. Solving for m, we add 4 to both sides. And we got m is less than negative 4. Or on the right side, we have to subtract 3 to both sides. And we get m is greater than 2. Okay? So this tells me where I need to graph. Negative 4 and positive 2. Negative 4 we're open, and we shade to the left. And at 2 we're open, and we shade to the right. So we start at negative infinity, we're open, and negative 4, open, union, open at 2, and it goes to positive infinity. Okay, does that make sense? Remember the negative infinity, that's what that means right there. Negative 4, 2, and then we go to infinity. Okay, so just by looking at your graph, that's where we get all that stuff for the interval notation. Okay? All right, once again, we've got the OR. Now, what are we dividing by? A negative. When you divide by a negative, we have to flip the sign. Okay? And 9 divided by negative 3 is negative 3. Now, on the right side, we have to subtract 2, and we get w is less than negative 6. Okay? Now, the only thing that's wrong with this is when we write it, I want my lowest number first. And so we're comparing negative 3 and negative 6. Well, negative 6 is smaller. So when I'm graphing that, I want my negative 6 first. And then my negative 3. So we just took this whole thing and put it there. And we just switched them up. Okay? Because now when we draw our graph, there we go. There's negative 6 and there's negative 3. Negative 6 we're open, and we shade to the left. At -3, we're closed, and then we shade to the right. Okay, so we start at -infinity and goes to -6. Union, we're closed at -3, and that goes to positive infinity. You guys starting to get a hang of it? Cool. Why don't you try number 4? Let's see if you can solve both of them, and then we'll work on the graph together. Pause the video, and good luck. Okay, when you're done with that, you should have gotten y is less than 1 or y is greater than 6. You didn't have any flips or anything to do there. So at 1, we're open and we shade to the left. And at 6, we're open and we shade to the right. And now putting that in interval notation, -infinity to 1, and it's open, union, open at 6, and that goes to positive infinity. All right. Number 5. Once again, key thing, or solve each one of these individually. We have to divide by 11 to get the n by itself, and to get -2 is greater than n, okay? And now we need to rewrite this because we want the n first and then the -2. I'm paying attention to who's it's pointing to. The inequality is pointing at the n. I'm going to make sure it's pointing at the n. Okay, and now over here on the right, we have to subtract 4 to both sides. And when you're done, you get n is greater than 0. Okay, so those are both in order now. Let's graph them. -2, we're open, so we shade to the left. And at n or 0, we're open and we shade to the right. Why don't you guys see if you can do the interval notation all on your own? You get -infinity and 2, both of those are open, and 0 and positive infinity, we're open there too. All right, number 6. Now, for the first part, to get that x all by itself, you have to multiply by the reciprocal, and it's -3. So -3 over 1, those cancel. When you multiply by a negative, you have to flip the sign. And -2 times -3 is +6, okay? We had to flip that. Now, on the right side, we have a little bit more work to do. We had to subtract 7, and then you get -2x is greater than or equal to -2. Divide both sides by -2. We're dividing by a negative. So once again, we have to flip the sign. Okay? And now, to make it look all nice and pretty, I want my lower number first, so x is less than or equal to 1, or x is greater than 6. Why don't you guys pause the video and see if you can do the next two parts all on your own. Good luck. Okay, and there you go. You should get -8 to 1 with a closed bracket for the 1. Union, open 6 to positive infinity. All right. Now, we need to solve and graph the compound inequality, and then use the graph to determine the solution of the inequality. if the given value is the solution. Sorry about that. So 7, you guys need to solve this, okay? Pause the video. Well, let's do the first one together, and then you can pause the video to try it, okay? So we have to subtract 3 to both sides. You get -10 is greater than or equal to -2m. You have to divide by a negative. So when you divide by a negative, you have to flip. Okay, and now at this point, we need to rewrite because we want the m first. It's pointing at the 5. Okay, now see if you can solve the second part all on your own. Good luck. Okay, when you're all done, you should get m is less than -5. Okay, so we got -5 over here and +5, because this is the part Mr. Grice just forgot. That's not my answer. Okay, we want these written in order. So m is less than -5 or m is greater than or equal to 5. So there we go. Now at -5, we're closed and we shade to the left. And we are not closed, Mr. Grice, we are open. 5, we're closed and we shade to the right. Okay? Putting that in interval notation, we've got parentheses -infinity to -5, parentheses union, closed at 5, and then open at infinity. Okay? Now, the question, is m equals -5 a solution? Now in class, everyone's like, yes, it's a solution because -5 is on your graph. Correct, -5 is on the graph. But my inequality, which is the one I'm covering up right there, m is less than -5. It's not equal to -5, it's less than. So is this a solution? No. All right, number 8. Number 8, I want you guys to solve this on your own. Okay? Make sure that you distribute and watch out for that negative sign. Those are your hints. Okay? Pause the video and good luck. Okay, there's all your work right there. She got n is less than -6 or n is greater than or equal to -3. Now remember on the first part, we had to rewrite that so the variable was first. And on the right side, we had to divide by a negative, so you had to flip the sign. Okay, so we're open at -6 and we're closed at -3. And then when we're writing this in interval notation, we start at -infinity to -6 and we're open. And then we're closed at -3 and that goes to +infinity. Okay? Now, is n equals -3 a solution? Well, yeah, because it's greater than or equal. So it can be equal. All right. Let's go ahead and do these ones together. Okay, on the left side, we have to distribute first. A lot of people got this part right here on the quiz wrong. -4 plus 1 is -3k. Okay, we have to subtract 4 to both sides. We get -3k is less than or equal to -12. And then what do we have to divide by? Okay, when you divide by a negative, we have to flip. Okay, now on the right side, I want our variables on one side, so I'm going to move the smaller variable, and we get 3k minus 1 is less than or equal to 8. We have to add 1 to both sides. You guys should be good at that by now. You get 3k is less than or equal to 9. And now we have to divide both sides by 3. And we get k is less than or equal to 3. Now, I need to look. Are those two in order from least to greatest? The answer is no. So we need to rewrite it. We have k is less than or equal to 3, or k is greater than or equal to 4. At 3, we are closed and we shade to the left. And at 4, we're closed and we shade to the right. Writing that in interval notation, negative infinity to 3 and we're closed, union, and then we're closed at 4 to positive infinity. So is k equals 0 a solution? Well, there's 2, there's 1, there's 0. Is it part of the solution? Answer? Yes, it is. Okay, it's shaded in. It's part of the answer. All right, number 10. Don't be scared with number 10. It looks like a lot of work, but it's really not. Okay, we're going to do the first one together, and I want you to try the second portion on your own. Okay, I want my variables on one side, so I'm going to move the smaller one, so I get to add 3w, and then we get 5w plus 8 is less than 8. We have to subtract 8 to both sides, and we get 5w is less than 0. We're not done because we have to divide both sides by 5, and 0 divided by 5 is 0. Okay? Now, why don't you guys pause the video and try 10 on your own. Okay. I'm going to go through this anyways, even if you did pause it. So good job if you tried it. You get negative 2w minus 2 is greater than negative 6w plus 7. We have to combine our like terms on the left side. So you get negative 2w minus 3 is greater than negative 6w plus 7. I want all my w's on the same side, so I'm going to add 6w. And now we have 4w minus 3 is greater than positive 7. Okay. Oh, I know what I did real quick. 1 minus 2, guys? Come on, negative 1. Mr. Grice, where are you at? Thankfully, that was a small change. Okay. We have to add 1 to both sides. You get 4w is greater than 8. And then divide both sides by 4. And we get w is greater than 2. So here's our answer. With that right there, we can go ahead and graph it. We got 0 and 2. 0, we're open and we shade to the left. 2, we're open and we shade to the right. Writing that in interval notation, we got negative infinity to 0, union, 2 to positive infinity, and everything has brackets. Okay, is negative 3 a solution to this? What do you think? Well, if you keep this going, -1, -2, -3, answer is yes. Okay? All right, guys. Well, that's it for Algebra 2, Chapter 3.8 notes. If you have any questions, please come see Ms. Carranza or myself because we would love to help you out. Thanks for watching.